In this lesson, we will be looking at rational inequalities. The steps to solve rational inequalities is similar. It's the same steps as solving rational equations. However, since the solution for inequalities, it's an interval of values, we have to do a check at the end in order to determine which intervals contain our solutions. All right, first example. So we still need to determine what x cannot equal. So x cannot, when we set that denominator equal to 0, we get x cannot equal -7. And then we determine what the lowest common denominator is, which is x plus 7. That's our only denominator. Multiply everything by x plus 7. The x plus 7's on the left side will cancel, leaving us with x plus 5. And then x plus 7 times 0 is still 0. Subtract 5 from both sides. We get x is greater than or equal to -5. All right, so now we're going to draw a number line, put 0 in the middle. And so we should have markers at -5 and also at -7. All right, so we've got at -7, x cannot, we want to determine the values in each one of those regions: less than -7, between -7 and -5, and then greater than -5. So -10 is less than -7. So when we plug in -10, we get a true statement. So that interval does contain solution values. Whenever we plug in a value between -7 and -5, like -6, it does not give us a true statement. So that interval does not contain solution values. And then lastly, when we plug in 0, which is a value that is greater than -5, we do get a true sentence. So that interval does contain values that are in our solution. So now we can write our solution in interval notation. So it's going to, the furthest left interval is going to go from -7 from negative infinity to -7, not including the -7, since we determined initially that x cannot equal -7. And then union should actually be a square bracket right here, because when we solve, we determine that x can be greater than or equal to -5. All right, so x can equal -5. And that interval will continue to positive infinity. And that is our solution set. Next example. First, we need to determine what x cannot equal by setting the denominator equal to 0. So when we set that denominator equal to 0, we determine that x cannot equal 4. And then the lowest common denominator is going to be 5x minus 20. We'll multiply both sides by 5x minus 20. 5x minus 20s on the left side will cancel, leaving us with negative 4x minus 29. Then on the right side, we'll have 5x minus 20. We'll add 29 to both sides. Actually added 4x to both sides and then added 20 to both sides to get negative 9 is less than or equal to 9x, and then divide both sides by 9. We get x is greater than or equal to negative 1. Draw our number line. We should have markers at negative 1 and at 4. So we want to plug in values that are less than negative 1, between negative 1 and 4, and also greater than 4. So negative 2 is less than negative 1. When we plug that in, we do get a true statement. So that interval does contain solution values. When we plug in 0, which is between negative 1 and 4, we do not get a true sentence. So that interval does not contain solution values. And then we plug in a value that's greater than 4, like 5. When we plug that in, we do get a true sentence. So we have the green indicates the intervals that contain our solution values. So the far left interval is from negative infinity to negative 1. And we are including the negative 1 because when we solve the inequality, we got x that can be greater than or equal to negative 1. So x can equal negative 1. So we should have a square bracket at negative 1. And then a union symbol. And then x cannot equal 4, so there we've got a parenthesis at 4, and that interval continues to positive infinity. All right, next example. Set the denominator equal to 0. We determine that x cannot equal 5. Lowest common denominator is 4x minus 20. Multiply both sides by 4x minus 20. And the 4x minus 20s cancel on the left side. When we distribute the negative 4 on the right side, we get negative 16x plus 80. And then we add 16x to both sides to get 21x on the left side. Subtract the 101 from both sides, we get negative 21 on the right side. Divide both sides by 21, we get x is less than or equal to negative 1. Draw our number line. We should have markers at negative 1 and at positive 5. Choose values that are less than negative 1, between negative 1 and 5, and greater than 5. Negative 2 is less than negative 1. When we plug in that value, we do not get a true sentence. So that interval does not contain our solution values. 0 is between negative 1 and 5. When we plug that in, we do get a solution. We do get a true sentence. So that interval does contain the solution values. And then when we plug in a value that's greater than 5, like 6, we do not get a true sentence. So that interval also does not contain any of the solution values. So to indicate that interval from negative 1 to 5, we should have a square bracket at negative 1 because, again, in our solution, we got x is less than or equal to negative 1. So we can have negative 1 as a solution. And that interval will extend to positive 5. And x cannot equal 5, so there should be a parenthesis. All right, last example. Set the denominators equal to 0. We get x cannot equal negative 7 or negative 6. Lowest common denominator is x plus 7 times x plus 6. Multiply both terms by the lowest common denominator. And the left side, the x plus 7s will cancel, leaving us with 15 times x plus 6. On the right side, the x plus 6s will cancel, leaving us with 14 times x plus 7. Distribute the 15 on the left side and then distribute the 14 on the right side. Subtract 14x from both sides and subtract 90 from both sides. That'll give us x is greater than 8. Draw your number line, 0 in the middle. Now we're going to have 3 markers. We should have a marker at -7, -6, and +8. So we're going to have to choose 1, 2, 3, 4 different values now. A value that's less than -7, between -7 and -6, between -6 and 8, and greater than 8. So when we plug in -7, we do not get a true sentence. So that interval does not contain the solutions. When we plug in -6.5, which is between -7 and -6, we do get a true sentence. So that interval does contain the solution values. When we plug in 0, which is between -6 and 8, we do not get a true sentence. So that interval does not contain our solutions. And then lastly, a value that's greater than 8, like 10. When we plug that in, we do get a true sentence. So that interval does contain solution values. And then writing that interval using interval notation, x cannot equal -7, so that we should have a parenthesis at -7, and that interval extends to -6. X can also not equal -6, so we should have a parenthesis after the -6, union, and then at 8, we have a greater than symbol, so 8, x cannot equal 8. It has to be greater than or it cannot be equal to 8 because we don't have a bar under the inequality. So that interval extends from 8 to +infinity.